Yes, good evening. Today we want to discuss about the QuickSort algorithm. I understand one time we discussed about the bubble sort, and it's a requirement from the ZIMSEC syllabus that we should acquaint or equip our learners with those two sorting algorithms, that is the bubble sort and the quick sort. Yesterday, if you still remember, the bubble sort we talked about, is it yesterday or the day before yesterday? I don't still remember, but we discussed about the bubble sort and we described the way it performs sorting, that it compares adjacent elements and it swaps if they are not in the desired order, or it leaves the compared elements in that order if they are in the desired order. That is uh, the issue of the bubble sort. So the quick sort now is a bit different from the bubble sort in that the quick sort it elects an element to one element is elected to be a pivot, and the rest of the elements are compared with the pivot. And when the comparison is made, what it means is after all the element has been compared with the pivot will be sorted. The pivot will be sorted, meaning to say that the pivot's position, its correct position, its correct final position will be identified and it will be placed on that position. But the other elements will not be sorted. Only the pivot will be what? Will be sorted. And from the position of the sorted pivot, the list would have been said being divided from the position of the pivot. So the list would have been said it has been divided from the position of the pivot, meaning to say that we will be having a sub list on the left hand side of the pivot and a sub list on the right hand side of the pivot. So it depends now with the arrangement of the elements, whether you're sorting in ascending or you're sorting in descending. What it means is if you're sorting in ascending, obviously by the end of the comparison of the pivot with the rest of the elements, all elements which are smaller than the pivot will go to the left hand side, and after comparison of the pivot with all the rest of the elements, and all elements greater than the pivot will be on the right hand side of the pivot. That's how the quicksort works. So I don't still remember whether I have a list of elements, a list of elements, a list of elements. Oh, I don't have a list of elements. This one's the issue of let me close it. Let me open a new text so that you put elements here. We can say 78. I understand used 78 yesterday. Can say 32. Can say 44, 87, 21, 39, 98, 52. something like that. I mean, 1 2 3 4 5 6 7 8. Let me add more. 2 more, 67. Have 67 no, then 72. Yeah, something like this. Yes, something like this. Excuse me. Hey, this floor, it seems I was cleaning somewhere. The dust entered my nasal cavity. Fine. These are our elements of our list. We normally make use of numbers because numbers, they're easy to arrange, they're easy to determine which is greater, which is not greater, or which is less than another. They are easier as compared to other types of data, which sometimes may be difficult to determine which one is greater than the other. So when you are describing a concept, that's why we prefer using numbers. But doesn't mean that these sorting algorithms, they are only used to sort numbers only. No, they may be used to sort any other types. But in this scenario, you will see that we concentrate more on numbers. But that doesn't mean that only numbers will be used, or only numbers will be sorted by these sorting algorithms. Right, so it depends with the method which one wants to use when electing the pivot. Election of the pivot does not have a formula, but personally I prefer taking the last element, being it a what? Being it the pivot. So in this scenario, we are saying we'll be taking 72. Our algorithm, which we are going to write, will take 72 as the pivot, and it will compare. Right, it will compare 72 with the rest of the elements. So here what we need to understand is we have our list, that's one parameter. We have our pivot, that's another parameter. We should have the starting position. Where are we going to start? Obviously we are starting on problem 0, that's the first index. So we must have the start index, the last index, and so we have the start index, the last index, and the position of the pivot, which we may call the p index, and the pivot, and the list. Those are the elements, or those are the variables which we are going to encounter. So since the QuickSort makes use of a recursion, that's why another day when I was with some colleagues, I told them that we need to talk about recursion before talking about the QuickSort algorithm, because the QuickSort algorithm, it employs, or it implements the concept of recursion, because we will be having two methods. One, a function that performs the partitioning or the election of the pivot and is putting the pivot on its correct position. Then the recursive algorithm, which is the QuickSort, which will recursively calls the method that is performing the partitioning, and it is the partitioning which makes us to change the position of the what? Of the index. So what happened is, if the element on the list, let's say we are sorting in ascending order, if the element within the list is smaller than the pivot, the position of the index has to increase. The position of the index has to increase with what? With the 1. In other words, there must be a swap. That is the current position within the loop and the predefined position of the pivot, that is the p index. Assuming that we will demonstrate it because sometimes putting it within the limits of words, sometimes people will not get it. We are saying that, like in this scenario, we compare, we may be having the p index, because we are saying, let me put indices here. We have 0, 1 here. Let me put 1, 2, 3, oh wait, it's the 4, 5, 6, 7, 8, 9. These are the indices, the positions. Oh, sorry, I wanted to push it. Anyway, let me leave it like that. Right. So the pivot now, our pivot in this scenario, assuming that this is our list of marks. Right, it's a list of marks. So our pivot, I said we are going to take the last index. So our pivot will be max 9. Then the position of the pivot now, that is the p index, is what? Is 0. The first position, we take the first position as the position of the index, because we haven't compared, we haven't made any comparison. So the first position by default becomes the position of the index, even if all elements are greater than the pivot. It will be not a problem. But if the elements are smaller than the pivot, that's why we said if the element which we are comparing to is smaller than the pivot, then the pivot index must be moved towards the right. That's what I'm saying. So if all elements are greater than the pivot, obviously we just take the pivot and put it on the first position. It's not a problem. But if the element is smaller than, then we need to move now the what? The position of the pivot, which is the p index. We move it towards the right side. Then the start index or the s index in this scenario will be what? Will be 0. Right. So as it is like this now we assuming that we have selected 72, that is max 9. 72 is our pivot. Since 72 is our pivot, we have to compare 78 with our elements there, right? So 78, in fact, we are saying, if we can say 78, this is the first, the max is 0. Oh yeah, because we'll be saying max 0 is less than what? 72. 78 is less than 72, which is false. So no need to perform some swapping there. Our p index will remain at what? At 0. We move to the next. We are now on max 1. Max 1 is less than 72, which is what? Which is true. So since it's true, what is going to happen here? 78 will swap with what? With 32. Not because the swapping is now taking place, the position of the index and the current position. So that's what we are saying. 72 and what? And 32 will swap here. So we have 78. Sorry, we have 32 here, then 78 there. Right. So it will be like this. Let me put it on top so that people will see what I'm saying. Right. It swap like the swap okay like this. And the p index has to increment with 1. So 0 plus 1, our p index will be at what? At 1. Right. We move to the next. 44 is less than 72. This is true. So 44 and 78 will what? Will swap. 78, 44, then 78 here. Right. Our p index will increment with the 1. So it's now pointing at 2. Right. Proceed to the next. max 3 is less than 72, which max 3 is 87. 87 is less than 72. This is false, so nothing will take place. Proceed to the next. 21 is less than 72, which is true. So our p index is 2, right? You need to see that our p index is what? Is 2. So max 2 now, which is 78. We'll swap with the current, that is 78 and what? And 21. So this one here, we have our 21, it comes here. Then our 78 will come here. Then our p index will increment with the 1, not 2. So our increment is now at what? At 3. And we were at our looping was at what? At 4. So we move to 5. 39 is less than 72. This is true. So a swap is going to take place. Our current versus the position of the index. So we are swapping 87 and 39. So here we put 39, here we put what? 87, like this. Then our p index has to move with what? With 1, becomes 4. Then it goes to the next, that is 6. 98 is less than 72, which is false. It goes to the next. 52 is less than 72. It's very true here. Remember, our p index is on what? On 4. So 4 and 7. The elements on 4 and 7 will swap. This is now 78 versus what? Versus 52. So, sorry. I'm supposed to put 52 here. Then 78 where 52 is, right? Then it has to increment with 1, like this, right? Then you proceed. 67 is less than 72, which is true. So 87 is 5, swaps with 67. 87 swaps with 67, like this, right? This is the last element. So when and this one has to increment, sorry, it has to increment with 1, right? When it reaches this stage now, finally, after it has finished the iteration, it has now to move, because this is the position of the index, position number 6. That's the position of the pivot, I mean, the p index, pivot index. So the pivot will swap with the element on position 6, meaning to say that the pivot now, the pivot 72 on 9, it swaps with position 6, right? So our 72 become here, 72, then our 90, it was 90, sorry, 98, right? So 72 and 98 will swap here, right? So the pivot, this pivot is now sorted. Even if you look, all elements on the left hand side here, they are less than the pivot, and all elements on the right hand side here are greater than the pivot. But this doesn't mean that the elements are sorted. The other elements are not yet sorted, but the pivot is sorted. So it will, the process now will be repeatedly done, because a new pivot will be elected on the left hand side, because it's like a new sub list, but it will not create a new, totally new sub list. It works, it makes use of in-memory sorting. So within the same list, it will perform sorting, but the sorting will start from 0 to 5. That is 6 minus 1. That becomes the last index. 6 minus 1 becomes the so using my method of electing the pivot, obviously 67 becomes the what? The pivot, and it repeatedly do what we were doing, and the position of 67 will be acquired. Then it goes to another, it goes like that until all elements have been what? Have been sorted. That's how the QuickSort works, because people should understand how QuickSort works. That's how it works. We are going to write the codes because we are going to have two separate methods, one for the partitioning and the other one for the QuickSort, the recursive QuickSort, and the other one will be the main program, now the main method, that which we will call the what the entire programs. That's what we are going to do. All right, so first we need to declare the what, the function partition. So now function partition, prefer to use the capital letter, partition, right, by val or by ref, depending with what you want. The first one, let's put it in array, a list, then as what, a list of integer. Yes, we need another one, probably that is the start point as integer, then the end point as integer again, right, and we return a position, so as what, as integer, because we are going to return our function is going to return the position of the pivot, right. So here we need to assign the value of this one, so this one equals to dot length minus 1, the length of the array minus 1, obviously st equals to, may put it at 0, but anyway it's not a much thing, because sometimes it may not be 0, it may be greater than that. So even this one, I don't think it's necessary for us to code like that, because here we are just writing our function. We will give it the actual value when we are coding in the main program. We're having the actual list, that's when we can give it the actual what, the actual value. So here what we can do is we can declare our pivot, dim pivot as integer, right, equals to a list, because I said we are taking the what, the last element to be the what, the pivot, right. We may also want the temporal for swapping, dim temp as integer, right. We can also declare I for iteration, because we need to loop from the start position up to the end, end minus 1, because obviously we don't want to include the pivot, so it will be end minus 1. So we can now perform the iteration, right, for I equals to start to en minus 1, right, next I, like this, because the reason is we are not going to reach the end, because if you can check here when we performed the comparison, oh, it's unfortunate that we swapped 72, but 72 we did not reach the 9, we ended at 8 when we were comparing, so that is the reason why we are subtracting minus 1, because we are comparing the pivot. The last position, that's where the pivot is according to my method, but doesn't mean that that's what is supposed to be done, because you may encounter someone who elects the pivot using the first or the third or whatever. Everything is permissible, because there is no strict rule of electing the pivot, right. Oh, I had forgot to declare the position of the index, which I was saying p index as integer equals to can put it as a start, because the start point is as the position of the index, right? Something like that, right? So now we want to iterate now. If fine, I'm used to C# to put those round brackets, but you can use it in VB, though it's not necessary anyway. So saying if I, right, is less than pivot, then we now want to move we want to swap, and we move the what, the P index, because the P index started on the starting position. Because why we are using starting position? But sometimes the starting position may change. It's not always that it will be 0. It may sometimes start at imagine when you are going to the right, it will be the pivot index plus 1. That becomes the starting position. That's why we are saying we cannot put 0 here. But putting 0 when you are going to the left hand side, it will work. But on the right hand side, it may not work. It will cause what? Cause problems. Right. So here we are now saying the temp, because we need to equals to AI, right? So AI equals to AP index, right? AP index equals to temp. There is no equal sign, the assignment placed there, right? Then P index now, not pivot, P index equals plus equals 1, which is the same as P index equals to P index plus 1, like this, right? Right. So after performing everything, we need now to swap the position of the last position of the pivot index, P index, and the position of the what, of the last element. The element on the P index and the element on the last position needs to what, needs to swap, because that's the last process which we also did. So we are saying you can say it was to pivot like this, it's not a problem. Then you now take element on the position of the pivot and place it on the last element. The last position here may change, because if it goes to the left, you still remember I said the last position will be the pivot position minus 1. That's why we're using what, we're using those en. So we're saying P index. So the element on the position of the index will goes to the what, then is this called, yeah, that's called, then the element. So here there was no need of putting that one temp, because pivot, obviously we are not using the pivot, so the temp here is not necessary. We could even avoid the temp on the last part, because P index can say like something like, so this line is not necessary, it's a repetition, because we are saying the last element, we put the element on the what, on the position of the index. Then on the position of the index, we just put the pivot, which is the same with the one which I have already put on the what, on the on the temp. So we return what? P index. Right. So this becomes our function. This becomes our function. This becomes right. Now we want to create the procedure, or the procedure, which, because the function returns a single value, a procedure does not return a single value. That's the ordinary definition of those two methods. So we want another method that does not return a single value, which is a sub routine. So you're saying sub quicksort. And then the easiest thing which you need to remember here, this will take the same parameters as the partition. Then st is integer, then en is integer. Yes, right. This is a subroutine, so that's the recursive now. So we are saying if st is less than en, then we can now dim p index as integer equals 2. We now call the partition, because the partition is the one which what performs the comparison of the pivot and the rest of the element, and retains the position of the what of the pivot. So you see partition A for this array, then st, that's our start, and en, that's our last. Right. As long as this condition is true, we now quicksort the what? We quicksort the list. Then we want to quicksort first, probably first the left hand side. So st remains as st, but the end becomes what? Position of index minus 1, like this. So we are now quick sorting the left hand side, and after quick sorting the left hand side, we need to quick sort the right hand side. So here again, the start position changes now, it becomes the position of the index plus 1, and but the end remains the what? Remains the same. So this becomes our recursive quicksort method. You see, quicksort is calling itself. So that's why. So the best condition, if you still remember, one I once talked about this recursion, that a recursion has got a best condition. So the best condition is the opposite of this one, because we said when the best condition has been reached, the calling of the method, self-calling of the method will be stopped. So here we are saying if st ceases to be less than en, that's the best condition, because this st is less than en is the general case, because that's where the quicksort is recursively calling itself. So that's what we need to understand. The best case, right? Right. On this one now, we now want to call all these methods, and we are only going to call the quicksort method, because the quicksort method is the one which we will call the partition. So let's declare our array dim array list as integer equals to and then we take here the numbers have been sorted. Hey, it's been changed here. Don't still remember the way I wrote them. Okay, let me try to put Control Z, Control Z, Control Z until I reach on 0. Right, so it means that that's the way it looks like. Take that one. Right, that's there. So here now we need to have the start, the end. I put F because if you write end is a reserved word. And yeah, those are the variables which are needed as what? As integer. Right. Obviously start equals to 0. Then n f end equals to the array list dot length minus 1. Right. So for us to see that this list, the list has been sorted, obviously we need to display it before sorting. For each num is integer in array list. We display the console dot write. Can say now we concatenate and vb table. Right, just console dot write line. What are we saying here? We are saying list before sorting. List before sorting. Right, we put write line here. Write line with the console, not just write line. Yeah, right, I want to put another one. I put this one. The sorting. Copy this one. So here we have to call the QuickSort. Right. So that's how this QuickSort works. Right, we are going to try to run and see how does it performs the what? The sorting. Right, the elements have been sorted in ascending order. The list after sorting, list before sorting. Yes, you may want to see the election of the pivot, like what we did, that 72 will be the first pivot that will be elected, and it we'll go down, 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 down. Let me try to add add some statements here before, right, before returning. So you can say here it's in A like this, right? Right line. The sorting process. At the list, okay, this is the sorting process. Right, so we need these ones. Something like this. Let's now try to see. Then we correct if it's not coming out as we want it. Right, something like this. So if you check, first 72 is sorted. Then next 67 is sorted. Next line 52 is sorted. Next line 39 is sorted. Next line 21 is sorted. So it goes, because it started with the left hand side, so it now comes to the right hand side, and until the sorting is done. So that's how sorting is done using the QuickSort algorithm. Yes, this is the sorting QuickSort algorithm. We have the function, the partitioning, we have the QuickSort procedure. The QuickSort procedure. We have the sub or the main procedure, the main method, main procedure. Right. So that's what makes up the QuickSort. Otherwise, I hope we have learned something, and don't forget the obvious thing: when you view this video on YouTube, make sure that you subscribe, you comment the areas which you want us to uh, create some tutorials. You give us some comments so that we know that what we are doing is of greater importance, or what we are doing is assisting someone, and also that those someones, they need a 1 2 3 ABC areas to be what, to be covered. But if you keep quiet, then it means it will not work for us. I say goodbye.